Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Hi. Okay, I think we're going to start now. I'm going to try to keep the lecture short. We'll try to do it in one hour's time. And then you need to do your own revision, because I understand that some of you might have some constraint. Financial ke, data plan ke, okay? So we'll try and keep it to 1 hour's time, all right? Okay, so today we're going to do chapter 3 of your textbook. I hope everybody has brought their textbook along home. Otherwise, you can use the resources that's available on the internet by using the materials on e-learning and my PowerPoint slide lah to guide you. Okay, all right. Okay, kejap Mana? Okay, so today let's look at shoot, yep. Oh, tak boleh lah. Sekejap. Okay, today we're going to look at parameter estimation of chapter 3 in your textbook, an introduction of parameter estimation, and one method on how to do parameter estimation, which is to use point estimation. Okay. Okay, in statistics, in the first class, I think I mentioned that statistics can be divided into two, which is descriptive statistics, and kejap sebentar. Oh god. Which is descriptive statistics. So this includes exploratory data. So if you have got a data set and you use graphs or percentage to explain about your data, like what you're seeing now with the COVID case, right? What they do is they have the observations and they do graphs to explain about the observations, or they use percentage to explain about the population or your observations. So this is part of descriptive statistics. Okay, that's the first thing you do when you have observations or data set. Another branch of statistics is called inferential statistics. So inferential statistics is comes from the word infer. So infer means conclude. So infer means conclude or deduce. Okay. Or in bahasa Melayu it called menyimpulkan. So apa yang you nak menyimpulkan? What do you want to infer? You're inferring from the samples in order to know more about the population. Okay, you're inferring, you have observation from your sample and you want to know more about the population. And in the syllabus we're going to look at two things: how to estimate, how to get those population parameter using your samples, and how to otherwise known as parameter estimation, and how to test the population parameter, otherwise known as hypothesis testing. So from now onwards you'll be looking at this part. Okay, how to estimate and how to test, i.e. Inferential statistics. In this lesson, we're going to look at one method of how to estimate your parameter. So I'd like you to remember this diagram again. I drew again and again. Population versus sample. So population, from the population, you can get many measurements. So you can get your mean, you can get your variance, you can get your standard deviation, you get your proportion. And if you've got observations and you calculate the mean from here, you call them population parameter. Otherwise known, population parameter. So for mean, the symbol is mu. Okay. And if you've got your observation and you calculate your mean or average as well, it's also called mean, but it has a different symbol, and it's called sample mean because it comes from your samples. Okay, so you need to remember all these symbols because later, when you have you're given some problem, you need to identify which of these information that's been given to you, because otherwise you'll be using a wrong formula. So here you need to remember all these symbols. So just remember, if it comes from the population, it has Greek letters, and if it comes from a sample, then it's got Roman letters. Okay, so for variance you've got for variance you've got sigma squared, and then you've got S squared for sample variance. Standard deviation, you've got population standard deviation, sigma, and sample standard deviation, S, and proportion, you got pi and P for your sample proportion. So the question is now, most of the time we've got samples, but we do not know the value of your parameter. So how do you estimate the parameter? How do you anggarkan? How you dapatkan nilai untuk this population parameter? So as I've said just now, you got your samples from here you can get your sample mean, but you do not know your population parameter mean, mu. So what you need to do is you want to estimate or anggarkan. So notice when you have an estimated value, you normally use a hat here to indicate that's not the real value, but it's just an estimate, an anggaran. Okay, but this anggaran is is an anggaran that can be used to say, okay, I know this population parameter now, which is mu, population mean. So there are two ways to estimate your population parameter. The first one is called point estimation. Okay, and the second one is called interval estimation, but normally people don't use interval estimation, they use the word confidence interval. Okay, so what is point estimation? Point estimation is when you estimate using a point estimate. Point estimate is just one single value, and this single value, it normally comes from a statistics. Okay, so for example, let's say you have mu hat equals to 10. So this 10 is a single value to represent mu hat. So one value. So if you have a point estimate, that means you only have one number. Okay, one number. So the value of this estimate is called a point. Sorry, not the value. So this is your estimate. 10 is your estimate, and the how you get how do the statistics used to get this value is called a point estimator. For example, you have okay. So for example, let's say you want to estimate the population mean. So population mean is one of the parameter. And you want to use the method of point estimate. So point estimate is normally the most simplest way because you only get that value from one value only. So let's say your population X say is normally distributed, okay, but you do not know its population mean. You don't know, so it's unknown population mean. So without derivation for this course, but actually there is a way to derive, but it turns out that the best estimate to use as your point estimate is your sample mean. Okay, so you want to know the population mean, You estimate from the sample mean. So therefore, your mu hat is actually x bar. Okay, which we can prove, but we're not going to prove in this course. Okay, so yeah, right. So for example, if you got a sample observations and you can calculate its x bar, which is 28.75. So mu hat is 28.75. Okay. Do you understand? Faham ke semua? You understand? Okay, great. Okay, alhamdulillah. Okay. Right. So what about other parameters? So if mu hat is x bar, so we're using a sample statistics to estimate your point estimate. So therefore, if you want to estimate population population variance, this is population variance and estimate of population variance, then you simply use a variance from your sample S squared. Similarly, for standard deviation, estimate of standard deviation, you can use sample standard deviation. And if you have a combination of both, then you can use let's say mu hat 1 minus mu hat 2, you can use x bar 1 minus x bar 2 and so on. Okay, so why do we use these estimates? As I said before, you can derive, but actually this is because, I mean, intuitively, because these estimates have all these properties. So if you have an unbiased estimator, so actually if you take the expectation of your sample set is x bar, you will get back your population mean. So it's an unbiased estimator. If you derive this, ex bar equals to mu, then therefore it's an unbiased estimator. So the best point estimate that you're using actually has a property of an efficient estimator in which it is not biased and it has a small variance. So these properties are important for you to have to be a candidate for the best point estimate. Okay. So let's say you've got observations and you've got an estimate value, you can actually check the precision of this point estimate using a standard error of the estimator and the mean squared error. This part is just for your knowledge, will not be included in your exam. I hope. Tak ada. Memang it is not. This is part of the theoretical part. Okay? Okay. Like, okay. Go to front. Okay. Okay, let's try and do end the slide. Okay, everyone. Um, what's the answer for question 1 then? What's the best description of a point estimate? You can all put your answers here on the chat. Put your answer on the chat. What's for question 1, dear? For question 1. Okay. Okay. All right. So most of you are saying B. Okay, so what's the best description? Okay, see, no, okay, right, okay. So I've got A B and A C. So the answer should be a B, a sample statistics. It is not an error because you don't have any values. You only have that one value. Okay, Azmil. So you want to estimate a parameter, you only have one value. So there won't be any margin of error. Margin of error is when you have some values to compare. But and it can't be an any value because it's going to be a special value. This special value is your sample statistic. So the answer is B. Can't be A because it's any value. So remember, if you want to do a point estimate, it has to be because you're going to estimate a parameter. A parameter is a very important thing because a parameter would represent your whole population. So if you see here, this parameter is very important. For example, let's say you want to estimate the rate of death in Malaysia, the average rate of death in Malaysia. You can't just use Johor as your you can't just use any value that's that so it has to be from a sample. You get your value from a sample observation that you have seen in other parts of the apa tu other parts of the apa namanya other parts of be a special value, a value that you can trust. So that value comes from information that you already know. So it has to be a sample statistics, and also because of this property, a sample statistic is an efficient has to be an efficient estimator. So for these properties, these would be your reasonable point estimate. So they are all sample statistics. Okay, Yusril? Okay. Okay, great. Right, let's look at B then. The point estimate is the point estimate is the what calculated for sample data used to estimate uh, the true value in the population called the what. Okay, what question 2. Read the question carefully. Okay, the point estimate is the what calculated from a sample data. A point estimate is any, this one is a general statement, right? This is a general statement. Okay. Anyone else wants to write down? Yes, it is not necessarily P hat. That's Antonius. That's right. This is a general statement. Okay. So yes. So the answer is A. Okay. Now, let's look at the answer. The selection of answer. Um, so P hat is, may I know whether P hat, what is P? Okay, some books, a hat means an estimate, okay? Some books may use different symbol lah, tapi for our case we'll use a pie. Should be a pie hat. Let me just put a pie hat, maybe a pie hat. Okay, pie hat here. Okay. So if you have a hat, that means you're talking about the population parameter. So apa tu? So this is a population. This is a population parameter. X bar is this is a population parameter for the proportion. Okay. So X bar is what? The sample statistics for the mean, right? So this is a specific answer, but the question asks for a general question. This is a general question, so it should be an A. The point estimate is the statistics calculated from the sample data. Because when you calculate from the sample data, this is essentially your statistics. You're estimating using a sample statistics. In this case, it's X bar. It could be okay, mu hat is always x bar. But if you want to say, let's say you want to find a sigma hat, then you should be taking S from your sample. Okay, so for this question it's B. Okay, let's look at the third question then. So question 2 is A. Okay. Let's look at the third question. Okay, when you have a question like this, which you will normally have, this is a typical, this is a very simple question, but the kind of question that you'll be asked for in exams or tests is a problem-based question. Okay, when it comes to a problem-based question, it's good for you to apa tu describe display your information. So just like I normally let's like what I did for the previous classes, try and what do you call that? Try and extract the information correctly and draw the diagram. Okay. So in this case, a shipment of 100,000 newly bought face masks has just arrived at the hospital. In general, the face masks have to conform to a standard measurement following the guideline from WHO. A sample size of 100 face masks are selected from the shipment to be inspected, and its mean and standard deviation of its measurements are given by 4.5 centimeters and 0.5 centimeters respectively. Okay, so the question is, so 100,000 is the sample size of what? So 100,000 is the sample size of population or sample. Okay, good. So here in this case, so you need to alamak, hello? Okay. So okay, good. So it is population. Okay, so it is from a population. So 100,000, 100K is the sample size of the population. Okay, so here it says a sample size of 100 face masks. So this is the sample size of the sample are selected from the shipment to be inspected, and its mean refers to the sample. Yeah, its mean and standard deviation is 4.5 and 0.5 centimeters. So how do you write the symbol for 4.5 centimeters? Or 4.5 centimeters. Okay, good. How do you write the symbol for 0.5 centimeters? How do you write the symbol for 0.5 centimeters? what's the difference between S and sigma? Aiman, what do you mean by sigma? How how do you find sigma? Aiman Shakir, how do you define sigma? So please remember this diagram. So it says standard deviation, yes. Standard deviation, it can be sigma or S, but sigma would come from the population and S would come from the sample. So here, sigma comes from the samples. Sorry, sigma comes. Correction. Now your standard deviation comes from the sample, so therefore it should be an S. Okay, Aiman. So here is how you write your sample. So here, so information that that you have is something like this. So you've got 100,000. If so, from the passage, you know that 0.5 comes from the sample. So it has to be a Roman letter here, 0.5. Okay, Aiman? Aiman Shakir? Okay, thank you. Right. So the question says, can you estimate the mean width for all the 100,000? That means you nak tahu what is the anggaran average untuk the population. So in this case, you know that sample statistics is X bar. So here you've got mu hat equals to 4.5. Okay. And the next question is, what is the best estimate for the population variance for 100,000? B. So kalau best estimate for the population variance, ni adalah apa? Best estimate for the population variance, how do you write this? For the population variance measurement, how do you write that symbol then? How do you write the symbol for the best estimate? Sigma hat. Yes, that's right. So sigma, yes, sigma squared hat. That's correct. Sigma squared. Well, strictly speaking, is a hat. But if you write sigma squared, it's fine as well. Okay. So here, therefore, here you've got sigma hat squared. Okay. 0.5 squared, which is 0.25. Okay, faham ke semua? So the basic concept adalah is that you want to estimate your population using apa nama dia? Using the sample. You want to estimate your population using a sample. So chapter is about that. You do not know, you start with not knowing the value of your population parameter. Okay? Right. Do you want to continue? We have another half an hour. Do you want to continue with the next chapter? No. No? Okay. Faham lah. Okay. No. Okay. Then faham. Okay. Tak apa. I want you to go back. So that's just it for the lesson today. I want you to go back and read part 2 pula. Alright? I've also put up. So if tak kisah, no, I mean tak kisah doktor. Jap. Okay. Tak apalah, tak apa. It's okay. I think we're going to stop here now. We're apa tu? Please read. Oh, remember. Yeah, of course. Thank you. Attendance. Yes, that's right. Don't worry much about attendance. I just want you to sebab I know some of you have got issues with internet and all. Okay, attendance, I will take your attendance. Tapi if you have issues on internet and all, I've put up the video version of my of the slide with narration. and you can listen to that. Okay, but it's good if you can tell me if you have issues. Kalau you have issues lah, on your internet. Okay, the point is you need to get that knowledge in. The news about the test, we are actually in the process of transforming your test to another form so that you can do it online. So it's still in the process. Okay, you need to still revise on your chapter 1 and chapter 2. If you have any issues, you can contact me um, individually. Okay, good job. Okay, I'll get your attendance. Okay. Attendance. Cup, cup. Tu apa? Tag tiga Slide in. Submit. Wait if you have problems with attendance, please WhatsApp me and I give you the code. YouTube channel, pergi kat please go to your e-learning. There's a link to my ni. I mean, you can go to my YouTube channel terus lah. But then you can go from my what do you call that? Check your e-learning. Kalau you tak tengok tu, maknanya you tak tengok mail. Please check your e-learning. That means you need to download the slide. I've got links to my videos there. It's basically the same thing that we have discussed here. Okay guys, apa tu if you have apa tu sign in for your attendance, you may go now. Okay? And please read and download, please download and read apa tu part 2. Okay, bye. Welcome. The best. Stay at home. Bye, tata. You too, Israel. Welcome, Luis. Welcome, Shafika. Yeah, Titi Tutu as well, Azmil. Bye, Antonio. Tonius. Bye, Aiman. Thank you, Moon. You're welcome, Kiam.